Hello, and welcome to another tutorial. Today we'll be going over using the timers that are built in with the Arduino Zero. To do this, we'll need to include two timer libraries. The timer TCC file will be used for timers 0, 1, and 2, and the timer.h file will be used for timers 3, 4, and 5. Before we jump into the code, however, we're going to look at our written tutorial sheet. At the end of our written tutorial sheet, which I highly recommend you read before we actually do this video tutorial, just so you have a better idea of what's going on. At the end of the sheet, we have an overview of all the timers and the conditions used within each timer. So as you can see, timers 0, 1, and 2 are done a little differently than timers 3, 4, and 5, so we're going to break it down into the two sets of timers for this tutorial. For timers 0, 1, and 2, you'll see that the frequency range is from 0.7 Hz to 3 MHz, whereas timers 3, 4, and 5 can go all the way up to 48 MHz theoretically. In practice, you're probably not going to get exactly to 48 MHz just because of the timing issues, but you can get relatively close to that. In order to start using these timers, you're going to need to set up the desired frequency you want these timers to run at. In order to do that, you're going to need to set a prescaler and a CCO scaler. The CCO scaler can be any 16-bit number, so that's 1 through 65,535, whereas the prescaler can be 16, 64, 256, or 1024. That's for timers 0 through 2, whereas for timers 3 through 5, the prescaler options include 1, 2, 4, and 8, along with the 16, 64, 256, and 1024. Now, in order to select your actual frequency, you're going to take 48 MHz divided by your prescaler times your CC0 value, and that will give you your desired frequency. So now we start looking at the code. The first thing you're going to do is declare the timer object variables you want to use. We do this at the top. Just make sure you use the right library for the right timers. Then we're going to begin our serial communication with the computer so we can see things through the serial monitor if we desire. And now, the fun part, we actually declare each timer and set that up. So to start it off, you're going to select the timer you want to use. Right here we select TCC0, and then you do 0 there as well. And you can see the same thing is going to happen on the interrupt to 1. You're going to do TCC1 and 1. Then you're going to use a config function, which will set up the variables in the background that need to be set up. You will then set your calculated prescaler and your calculated CC0 value. For your prescaler, it's just going to be right after the div. You're going to put your desired prescaler there. And then in the CC0 value, you're just going to put it within the parentheses there. And then last but not least, you need to just enable the timer, and that will start the timer running. If you go down to timers 3 through 5, it's pretty much the same thing, but instead for TCC in your number, it's just TC3 followed by 3. Everything else is the same, other than, as I said, you have more options for your prescaler. Lastly, for this demo, we're going to go ahead and set pins 1 through 6 to outputs so that we can actually measure on our oscope to make sure we're getting our desired frequencies. So now when we look at our actual timer interrupt handler down here, you will see that all the stuff we want to happen at this frequency needs to be within this if timer0.checkFlag statement. So for this example, all we're going to do is we're going to write a pin high. So we're going to write it to 1, which is high. And then we're going to delay for 10 microseconds just so the oscope can actually pick up the signal. And then we're going to set it back low. And as you can see, we do the same thing for every single one of these timer handlers. It's the same method for all of them. So now we're going to turn on the webcam and show you what this looks like on the oscope. Okay, so here we're looking at our PCB board, and as you can see, I have this oscope pin. I'm plugging it into pin 1. And now if we look at the oscope, you can see right on the bottom middle there, we're running at 800 Hz a second, and then if you look at our code, we set it up for 800 Hz a second. And if I go ahead and move the pin 1 down, we get 400 Hz, which is exactly what we want. If we move it down 1 more, we get 100 Hz. As you can see, this is how you test your outputs using an oscope, and it works really smoothly. One last thing I'd like to mention before ending this tutorial is if you go back down here to the actual timer handler, you'll notice that I was using delay microseconds instead of just a normal delay function. That's because if you use a delay function while using timers, it can actually mess up your timer's frequency. So it's really important just to remember to type in delay microseconds and then just multiply everything by 1,000. That's about all I needed to mention for this tutorial, and I hope it helped.